As you can see, the title of our presentation today is Python for Professionals, a complete guide to Enthought's technical training courses. My name is Mike Connell. I'm Vice President of Training Solutions at Enthought. And we're going to spend the bulk of our time, as promised, on our training portfolio. But I want to start with a brief kind of overview of Enthought and who we are, for those of you who may not be familiar with everything we do. We'll have time, hopefully, at the end for Q&A, but you should feel free to type questions into the questions box at any time during the presentation, and my colleague Courtney will respond if she can live, and then what we can't respond to there we'll batch up and take at the end. Just a note that everyone who registered for this live session will also get a link to the recording. Okay. So Enthought is a global leader in scientific and analytic computing. What that means is we don't write accounting software, we don't write games. Those are kind of applications that are divorced from any kind of domain in the world. We work with companies like geophysics, oil and gas exploration, where they have a lot of data, they have scientific models, they have experts, and what they want to do is they want to bring that knowledge and work with it in the computational realm so that they can take months of analysis on their core samples and kind of speed it up down to hours or minutes or days. And we do that, we've worked with hedge funds and banks in finance. We've worked with test flights. You can imagine lots of sensors coming in off a new jet plane, and it can take a really long time to analyze the data from those flights and figure out if there are any flaws in the design or anything like that. We can actually help them to bring all that into a single dashboard and really speed up the analysis and do much, much more with their data. So that's the kind of work that we do. And we do that with broad capability set. We do consulting, training, we provide software, and we also provide support. And I'll talk a little bit more about that in a second. We have a large user base. We have over 1 million downloads of our software products, and we are headquartered in the US in Austin, Texas. We also have global offices in Cambridge in the United Kingdom and in Mumbai, India. So I'm not going to go over every bullet point here, but just want to highlight some things. In consulting, we've worked in a broad range of domains, as you can see. We've done a lot of work in finance, oil and gas, aerospace, biotech, consumer products, and a whole bunch of other industries that we've worked in. In terms of software and support, Python being an open source set of technologies, just as with Linux you had Red Hat, you need somebody who can package all of that material up, make sure it's up to date, do the testing on the packages. So that's part of what we provide, is that bottom layer. The Enthought Python distribution is a distribution of Python for this kind of work. And then on top of that, we've tried to make it really easy to manage your Python environment and do the work. So everything from installing packages and maintaining the dependencies between them, editing, debugging, and then all the way through to deployment, which can also be a bit of a bear with Python, but we try to make that really easy. We have a couple of technologies that integrate with other software packages. So we have Pixel, which connects Python with Excel, and we have an integration toolkit for LabVIEW. We've done some large-scale kind of commercial software in the oil and gas industry, all written in Python, which does the same kind of work. It's kind of analysis using machine learning and some other methods to analyze cores of the earth that are taken out so they can more rapidly figure out where the oil is. In terms of training, we also have a broad capability set there. We have an online platform called Enthought Training on Demand. I've talked about that at length elsewhere, so I'll just mention it here. We also have done virtual training, which means a live instructor teaching over the internet to people who are remote. The most commonly we've done that with the Pandas Crash Course, virtual course. It's a day-and-a-half long. I'm not going to talk much about that today, but the content overlaps with some of the other courses I'll talk about. What I'm going to talk about right now is our on-site classes, which are still the gold standard for learning and also the bulk of our training. We do most of our live training in the United States, Canada, and Europe. We've also done some in the Middle East and Far East. And we have two kinds of training classes. We have corporate on-site. So if you're with an organization that needs training for a group of people, we're happy to come wherever you are and deliver it at your facility, if that makes sense. And then we have open classes for individuals, who want to register a loan. You can do that in open courses, or for small groups at companies that don't have enough people to warrant their own on-site. Sometimes they can always come to an open course, and sometimes we can even hold an open course in their city if they can anchor it. So I'm going to talk mainly about these 5 kind of standard classes in our portfolio. All right, so before I jump into what the classes are, I wanted to talk briefly about our approach to training. My own background is in learning science, and my interest has been in how do we take insights about how the brain and mind work and how learning happens biologically and psychologically, and use that to make more effective and more engaging training experiences. So just to give you a couple of examples that we can use to frame this conversation, one principle that often gets lost actually is that learning takes time. You can't just blast people with a fast stream of information and expect that their brains will record it like some sort of video recorder or something. The brain just doesn't work like that. So we need to take seriously the limits on how much information people can absorb in a given amount of time, the biological limits. So that has a couple of corollaries, one of which is we sometimes get customers saying, well, we want to do twice as much content in half the time, and our people are really smart. And that just doesn't work. And the reason is you can, of course, cover a whole bunch of content in a short amount of time, but there's this invisible threshold where the brain can no longer keep up. And once you cross that threshold for somebody, you actually put more and more content in, and they get less and less learning out. So there's kind of a bump function. And so that's something that we need to take very seriously. And you'll see that reflected in our designs. Another corollary to that is that there's a trade-off between the scope of content that we're covering and the depth of learning. So what that means is you can see here in this visualization that you can think of the sort of breadth. We could cover a lot, let's say we have a day of training. We could cover a lot of concepts, 100 concepts in that day through lectures, and just keep moving from one to the next and blasting people. What you get is kind of a superficial awareness of some of those concepts, which quickly drains away after the training. You feel full, you feel like you got a lot, but then you go back to work and you can't necessarily do anything differently. That actually can be useful in some cases, right? It depends on your goals. If you want people to have awareness of a landscape, a new landscape that they're kind of entering, then that's not a bad idea. Sometimes if it's for entertainment, that's not a bad idea. If you want people, though, to walk away with skills, you need to actually drill deeper in this stack of knowledge types. And what that means is we have to shrink down the number of concepts, the breadth, and we can focus on maybe a couple at depth in the same amount of time that we could cover 100 superficially. So we just always have to be mindful that this is what we're trading off as we're cutting through this space in different ways, and we only have limited time. So we got to be choiceful about that. So one thing we found to be kind of a sweet spot for for people who take our trainings, more than a week is difficult for organizations to do training often. So 1 week seems to be about kind of the optimal unit for a big course. And so given that, and given where people start and where they want to end up, we found that a sweet spot is kind of getting them skills on the most important concepts, and right at that level where they can, without too much trouble, they can go back to work and transfer it. Because it's one thing, you can do something in the classroom, and then can you get back and use it at work? We try to get you right at that edge where we can kind of maximize the number of things that we're teaching you, but at a depth that makes it easy to apply. Another principle is that you have to match the type of activity to the type of learning that you want. So you can do concepts with lectures, but if you want skills, you've got to do exercises. You can't learn to ride a bike, for example, by watching lectures, and you can't learn to do data analysis or programming either, just from lecture alone. And that's, and exercises take more time per concept, so that's part of the reason that this picture looks the way it does. So you'll see in our designs that typically 40 to 60% of our classes are interactive in some way. It's finger exercises, it's Q&A, it's exercises, and then there's a project in one of the classes. So really trying to make sure that we get a solid foundation that's really usable immediately. All right, so the first course I want to talk about is called Python Foundations. It's 3 days long. It's really the core for anyone who wants to use Python for anything related to data, right? If you're writing accounting software, you don't need this class. But if you're doing anything in science, engineering, analysis, data science, modeling, simulation, anything like that, this is a core set of things that everybody needs. And as far as prereqs for this course, you don't need any Python experience coming in. We do expect, though, because we move pretty quickly, that you need to be comfortable with general programming concepts, like what's a variable, what's a loop and why do you need one, and what's a function and how do they work in some programming language. So that could be a macro language in Excel, or it could be Visual Basic or Java, it could be MATLAB or SAS, just some exposure to computational concepts. All right, so in other words, sometimes we hear people say, programming's not my job, I just have to do it every day, right? That's the kind of person we're talking about, is they write software, but that's not the goal. The goal is to write the software to do something else. All right, so let me just walk through the layers here. The Python language, in terms of what we cover. First, you need to know about the tools of the environment. So there's the Python interpreter, the interactive Python shell, the Jupyter notebooks are two different interfaces to that. And it's different from the plain vanilla interpreter, so you need to know what's special about it for this kind of work. Managing your packages, we have a package manager, an editor, debugger, of course, you know, understanding how the help and documentation work. So that's really getting you set up to do the work. And then we jump into the core. We've really tried to curate out the 20% of the Python language that people need 80% of the time, so that you can get up and running quickly, do most of the things you need to do, and then be able to learn quickly the other things. So data structures, there's a handful that are the workhorses that virtually every program uses one or more of, you know, from integers and other numerical types. Those are kind of the primitive types up through more complicated structures like dictionaries. Then we move into control flow. You need to know how to do branching logic, if-then statements, how to repeat processes with while and for loops, and then there are some special looping patterns in Python that will teach you, list comprehensions and other Pythonic patterns. And then finally, if you're going to write any non-trivial code that you expect to use for any length of time or to share with people, you really need to kind of know how to structure your code. So, you know, managing complexity with functions, and then understanding how functions in Python work, which could be a little different from other languages you've seen. And then modules, which are if you want to have your code organized into multiple files that you can reuse and control the complexity that way. So that's the Python language layer. And then one of the things that's great about Python is it's got this really clean syntax for array programming. So you can, you know, you might say C equals A plus B, where you've got integers, you know, 1 plus 3 is 4. But you can do the same kind of syntax with arrays in Python, which is fantastic. So you can work with, you know, vectors or large tables of data with very, very concise language and not have to do loops and things. So you need to understand that paradigm with NumPy. And so we introduced the data structure. How do you define and create these things? How do you access and slice and dice the data? And then once you understand that, we move into computing with arrays. So, you know, how do you sum things? How do you do statistics? How do you transpose and reshape them to do your computing? And then hand in glove with that, often, right, the first thing you do is you load your data, and the second thing you do is you look at it to see if it loaded correctly, to see what you've got, that sort of thing. So matplotlib is the main library for plotting and visualization in Python. And so we give you, again, the kind of curated core concepts that you need to understand so that you can build on that later and get started immediately and build on it. So figures and subplots are kind of the main constructs, and then the four, you know, common types of plots: line, scatter, image, plots, and then histograms. And there are many other plotting packages, and in some of our courses we introduce some of those, but matplotlib, they're all pretty much based on matplotlib, and that's the most powerful, most general toolkit. So understanding that is important. Okay, then on top of that we have Pandas Essentials, and this is the key things you need to know about Pandas. Now Pandas is interesting because, well, for a few reasons. It brings new capabilities like time series analysis and dealing with dates and times in a very simple way, which was a bear before. But it's also kind of like the cockpit, where they've done a great job pulling in functionality from a lot of different packages. So they've got kind of the basic plotting functions in Pandas. So you don't have to like deal with another package. And also a lot of the just a lot of functionality that's been brought in for loading data, for visualizing, and that sort of thing. So we teach the Pandas data structures that are new: series and data frame. Data frame is very similar to the R data frame. The index is new and super important. And then we've got kind of the phases of data analysis here: data wrangling, loading, visualizing, slicing and dicing, dealing with missing data to clean it up, dealing with dates and times, which often is a problem on loading. And then once you've got your data rectangular and all cleaned up, how do I compute with it? So, how do I do reduction operations, like I said, like sums or averages? How do I do statistics? How do I transform the data? And then there's a whole bunch of data manipulation that you can do. If you've got groups of people like men and women, and you want to perform a computation on those two groups using the mean of that group, the syntax in Pandas is fantastic. You can really just kind of split things into groups with a single line, and then with another single line you can do the operation and then recombine them. Often you're pulling data from multiple different sources, so merging is really important, and then pivoting to look at your data in different ways. So that's the core. That's kind of the essentials in your toolkit for everybody. Let me show you some sample materials from kind of lecture and some of the low-level exercises. So this is from the Pandas Essential section. It's the Pandas plotting basics. And first we introduce the object model that we're building on, so you have that in your head, so that everything's not a mystery, right? When something bizarre happens or when you need to do something new, it's not like you have to go searching in a haystack, right, to find that needle, because you really understand it, so you know what you're looking for. And then we'll kind of walk through, like, what do I need to do to get set up? So you can see this is not just APIs, it's also practical workflow kind of insight. So each of the interfaces, whether you're writing a .py file script or a Jupyter notebook or a Python prompt, you have a different way to kind of set up to use Matplotlib for this kind of interactive analysis. So we show you those. And this code is also there for a reference later, and it's also, you can copy and paste it. So it's a little kind of snippet library that you can use in your own programs to get the work done. So that's fairly typical. And then we move through and kind of walk through, again, concept and practice of how do I create a line plot? How does the code map onto the parts of the picture? And then we move into subplots, and then the other types of plots, so scatter plot, histogram. And you can see the syntax is very, very succinct here. You can kind of do your plot in Pandas. Once you've created your data frame, df2 there, you can just tell it I want a scatter plot, and here are the dimensions of my data frame they want to use. So it's really, really clean and succinct. So that's fairly typical. We kind of introduce the concepts, and then, like I said, we can't just give you concept after concept and expect you to absorb it. You need to do something with it, and it should be something hands-on. So we have all of these, what we call finger exercises throughout the trainings. And we give you the starter code there at the top to create a data frame, and then you're supposed to do the exercises 1, 2, and 3 below in your own interpreter. And so this is fun, it keeps it interesting. It also makes sure that you get it, right? If you can do this, then you get it, and you'll be able to do it again. And if you don't get it, then it'll raise the issues, and the instructor can help immediately and clarify any misconceptions. So that's that's really kind of the core design, really. The exercises I think of as the backbone of the course, and the lectures are there to support the exercises. Okay, so these are very low-level exercises. I'll show you more meaty, complex ones later. Okay, and so we also provide this kind of work aid, these cheat sheets for the Pandas part. And this is the plotting cheat sheet. There are 8 of these. I'll show you the link later where you can get them. But it's kind of a work aid, and it's another piece of I think it was the training that you can take back and hang up on your corkboard and have there for reference, so that everything you learned in that part of the course is available to you. All right, so that's the 3-day course, and we teach that. That's the most frequent course I think that we teach. We also have created a series of 5-day courses that are tailored now to specific role requirements. So we take that 3-day base and we add 2-day snap-in modules for different roles. One for scientists and engineers, one for data science, and one for data analysis more generally. So let's talk about this one. Python for scientists and engineers is a 5-day course. And really what we've found through over a decade of kind of doing the consulting and doing the training is we've curated out what a lot of folks who are doing engineering and science work need is they're doing modeling and analysis with a focus on automated or semi-automated processes. And so often they need, as part of that, they need to create simple graphical user interface type tools to streamline their workflows for themselves, because they're getting the same kind of data set, but they need to look at it, play with it, explore it, and then set some parameters so they kind of create some widgets so they can do that. And then sometimes that's because they need to collaborate with other people who don't know the programming language, and so this creates an interface where they can collaborate together. And then the other thing we found that a lot of people have is they have legacy libraries written in C or some other language. Like you might have a simulation library that you've been using for 10 years in your group, and you need to access that. Well, Python's fantastic for kind of interfacing with other languages, and that is another thing that we teach in this class. Prereqs are essentially the same as for the 3-day class. You don't need Python, but you should be comfortable with general programming concepts. So here, so it's the 3 days I already showed you, plus these additional topics in the final 2 days. One of the things you need is you're writing a little bit more software than somebody who's doing kind of pure interactive analysis, and so software craftsmanship principles become important. How do you structure your code? Object-oriented programming is often very important for simulations and these kinds of workflow tools. Coding standards, coding organization, testing your code, timing and profiling your code for performance, debugging, and then monitoring execution. These are all kind of part of the craft of engineering software that's robust and that you can share and that other people can understand and use, and that is maintainable over time. So that's important for a lot of people. I already talked about interfacing with other languages. There's a number of ways to do that just with C and C++ plus other languages. We talk about a few to show you how it works, wrapping C code by hand. C types, Python are 3 ways to do that. And then the last 2 parts are really about building GUIs. So there's this package that we've created that's open source called Traits and Traits UI, and you can rapidly build graphical user interfaces for your programs, where you can add sliders and buttons and text boxes and stuff to set parameters and try things out. And then we teach you how to organize your GUIs using the model view controller paradigm. And then there's a couple of powerful packages for interactive visualization that interact with the traits model very well. So you can create kind of scatter line plots with Chaco 2D plots, and kind of out of the box you get a lot of free functionality. You can pan and zoom, you can sort of circle a bunch of points and it'll filter just those out. So you get a lot of interactivity. It's kind of Tableau-like functionality that you can embed in your larger programs. And then Mojave is kind of analogous to that, but for 3D data. So some pretty powerful tools to get going very quickly with creating those kinds of tools and applications. Okay, so that's what a lot of scientists and engineers need, we've found, is that set of tools, and we've made it fit into a week, and we make sure that we give them the tools they absolutely need the most, and make sure that we develop those skills so they can use it on Monday morning. Next in the lineup is Python for Data Science. That's another 5-day course, similar kind of structure, 3-day base that we saw before, plus tools specific to this role. So the audience here is people who do modeling analysis, right? But the emphasis here is more on interactive or exploratory analysis. You're not sort of doing repeated workflows with human oversight. You're kind of getting new data, and you've got to figure out what's there and what to do with it and where the insights are. So that's kind of more, I mean, you might then automate it, right? But often that also gets handed off to another group. So the folks here are doing this kind of work all the time. And also applying the tools of machine learning. So that's kind of the key things in terms of the audience. Prereqs, the first 2 are the same we've seen before. The third one is in a week, right, and 2 days of kind of the data science focus. We can't reasonably teach you all of statistics and all of machine learning theory, right? That's something people take semesters or years in college and grad school to learn. So we expect you to have taken a stats class to know something about machine learning, kind of, in principle, and generally how data analysis goes. We do, of course, introduce the models and explain them when we introduce them. It's just we don't have time to go into deep development of mastery of that stuff. But we're going to teach you deeply how to use scikit-learn and the tools that are in Python for doing the work, for leveraging that other expertise. All right, so again, the 3-day base we looked at before. Here are the additional topics for this class. Database access is really important for these folks, so we show a couple of ways to do that. Visual exploration, they have Matplotlib, which is still extremely important, but also Seaborn is a really great tool for doing the kinds of, a lot of the time when you're doing data science kind of work, you've got high dimensional data sets, lots of variables, and you need to look at the bivariate plots between any 2 variables, and so Seaborn's great for creating kind of grids of plots like that and other compact visualizations with a lot of variables. So we introduced that. And then kind of the workflow here is for the data science workflow. So there's a lot around pre-processing the data, right? Dealing with outliers, normalizing, dealing with missing values, and dimensionality reduction, like, principal components analysis, so that you can reduce your 5,000 variables to 100. And then we move into regression and classification, and there are lots of models for each of those. We show you some of the most common ones and some of the ones that are representative of classes of those. So we show linear models for regression, support vector regression, decision trees, and then there are issues, of course, that arise when you're doing this kind of work, right? So how to watch out for overfitting, what is it, how to avoid it, and then some of the trade-offs, like the bias variance trade-off that you have to think about in terms of how you're going to create the best model you can. Classification, similarly, lots of different models. We introduce a few of the most common: linear models, multiple class models, maximum margin, support vector machines, etc. And then we have a module on model selection, like, okay, so I've got all these possible models, how do I evaluate them and choose the best one? So we show cross-validation, and then we also show you how to use pipelines in scikit-learn so that you can automate the validation using something like grid search CV. If time permits, we sometimes have time to do some natural language processing with NLTK, the Natural Language Toolkit. But that depends on kind of the pace of the course and all. All right, let me show you real quick a sample exercise. So I showed you finger exercises before along with the lecture, and really those are paired together so that you can kind of anchor the concepts taught in the lectures immediately. This is more of a media kind of applied exercise. So this is typical. We give you the setup here, and then we give you some exercises to do, and then we might give you some starter code. So here we've got a database of face images, and what we want to do is we want to do a principal components analysis to come up with a more compact representation of all those faces. And so this is what we start you with, is we show you how to get the faces, and then we ask you to do a number of things. And so then you work on it, the instructor walks around and supports you and answers questions and all that. And then you have a debrief, and they'll walk you through kind of an answer. So here, right, you do the decomposition. One of the questions is how many components do you need to get 95% of the variance in the original set? So you had 96 features originally. You can get down to 123 components. And then we display the average face. So that's what if you average all the faces in the database, that's what the kind of prototypical face looks like. Then we can look at the principal components. That's pretty cool. This is what the thing extracted, right? You can see what it is. It's kind of eyes and relationships between features and mouth and sort of that sort of thing. So those are the first 12 principal components. And then at the end, we say, okay, now take one face, and that's the original on the left, and we want you to project it onto your reduced space and see what it looks like. So that's the reconstructed image on the right. It's got less information. It's more compact. And yet it still is recognizable, so it's pretty good model there. So that's fairly typical of the exercises. Some are smaller, some are much bigger. We have a big project that spans a couple of days for one class, and so just to give you the flavor of that's a real problem that you can see how once you've figured out how to do that, taking it back to whatever you're working on should be fairly straightforward. Okay, so the last big one is Python for Data Analysis. That's a 5-day course. This one's it's similar, right? It's got the same 3-day base. And what we're doing here is we're expanding out the Pandas essentials into a richer, more comprehensive, and deeper treatment of Pandas, so more expert level. And we can do that because we've really narrowed, if we look at the picture, we've really narrowed the scope to Pandas. We're only teaching that one package, and so we have now the time to do more depth. The other reason is we get a lot of requests for pandas, more pandas all the time. So the reason is because this is really, like I said, the cockpit. No matter what you're doing, if you're working with tabular data, pandas is for you. If you're doing exploratory analysis, if you spend a lot of time cleaning data, wrangling it, preparing it, pandas is for you. If you're doing anything interactive in Python, pandas is for you. So even if you're using other tools, right, other packages for some of the modeling and analysis, this is usually like 80% of the work is getting your data ready, and so pandas is the place to do that. sample roles are, or examples of roles, quantitative analysts, data scientists, business analysts. Actually, Pandas was created in the finance industry, so quants there. And in fact, anyone migrating to Python from a data analysis tool like Excel, right, which is tabular data, or R with the data frame here is very similar, SAS or MATLAB, this is going to be your point of entry into the ecosystem. And it actually, you can do a lot of your work right there. And it may actually be your final destination. You know, you can, it's seamless to move from Pandas into other packages like scikit-learn. So that's great too, because you can expand it easily, but a lot of the work just gets done here. So that's why it's worth spending more time on Pandas. Let's see, so prereqs, the first two again are the same. It's the prereq for the whole thing. You know, and here it's recommended but not required that you have general knowledge of data analysis techniques and basic stats, right? So you should know what an average is, you should know what a standard deviation is, and so on, but nothing heavy duty there. That helps, it's not required. All right, so I've shown you the text in black at the bottom here is the topics we've already seen from the Python Essentials. The ones in red are new topics. So, so with the expanded Pandas content, we do database access, and then we do some more data manipulation, like joining, not just merging, but joining, kind of like SQL joins. Reshaping your data frames, multi-level indices, so you can do some pretty sophisticated stuff very, very quickly with these additional tools. So we've expanded the scope. Right? We've gone from 1 to 3s, and part of it is we've expanded the content, the scope, but we've also added more exercises throughout. So we're really trying to push more of these concepts down to the skills level. And in fact, we've added a project, which takes us even further down, and I'll show you that in just a second. So, so this is the Python for Data Analysis 5-day class. If you drop just the first 2 days up through Matplotlib, you end up with what we call the Pandas Mastery Workshop. And if you already meet the prereqs for the other class, then this class is good for you. But you need to know coming in, whereas you didn't for the other one. There were no Python prereqs here. You need to know something about Python. You've got to know data structures, control flow, assignment, functions, package access. And if you've been using it and you know those things reasonably well, then you can jump right into Pandas. Also, you need to know array programming and NumPy. You need to be familiar with that. Just because the paradigm is different from programming in other kinds of languages, and it's kind of how Pandas work. So you need to have that mental model. Otherwise, the similar kind of general data analysis techniques is recommended. So to meet these prereqs, you could have been working in Python for a while, or if you've taken any of our other classes that have that Python Foundations component for the first 3 days, then you've met the prereqs, right? Python for scientists and engineers, Python for data science, or Python Foundations. All right. Okay, so this is what the block schedule looks like, and I'm showing you this because I wanted to show the project piece. Really here what we're trying to do is we're trying to move deeper into the transferable skills so that when you get to work on Monday, it's like you've already done a project, Often you go to training and you go back to work, and that first project is the final part of the training where you've figured out how to apply all of that you learned to your work. Here we give you a project and we say, okay, go do it, and that's the first project, and now you've got an expert in the room to help you get through it, and you can ask any additional questions that might be relevant to your work and so on. Plus, you're having to deal with all of those questions that, in a focused exercise that's kind of surgically scoped to work on one concept or one skill. Here you actually have to deal with the messiness. We give you a bunch of messy data sets, and you've got to figure out all that top-level stuff that you've got to make choices about, strategic choices about trade-offs and things, which is really important. So the way it's organized is we kind of teach you the basics: loading data, data structures, visualizing and preparing the data, saving it out, and then you work on the project part for that. So we give you a bunch of dirty data sets and you load them and visualize them. You apply all that stuff to the project. And then we go back and we teach you the dates and times, combining data frames, reshaping, and so on. And then you do the more heavy-duty analysis part in the second half of the project. And how this kind of gets laid out in practice depends on, the pacing of the class and stuff, depending on the capability of the students. Okay. So the cheat sheets are available. You can go to this web link here and get them. There are 8 of them. They're beautiful. They're very useful. It's more than just APIs, as you can maybe see here, is we've got snippets of code, we've got gotchas, we've got recommendations. So really very thoughtfully done. Feel free to share them. They're licensed to share, or print them out and put them by your desk. All right, so just to summarize that bit about the portfolio, right? We have Python Foundations. That's a 3-day class. It's for anyone using Python for data-related work. And from that, we derive 3 classes that are tailored to different roles: scientists and engineers. That's a 5-day class. Python for data science is a 5-day class. And Python for data analysis is a 5-day class. And those are for those different roles. And, then we have this 3-day Pandas Mastery Workshop, which is just the Pandas component of the Python for data analysis class. Okay, and we've had people take the data science and the Pandas Mastery Workshop, and they've found that quite useful. So let me give you a flavor for what people say about our classes. So this is the guy, in fact, who had taken both of those. He said after he finished both the data science and the Mastery Workshop classes, he felt like he could tackle even the ugliest data sets. He mentions how great our teachers are, how knowledgeable, and what a great job they do explaining tricky topics easily and with clarity. Highly recommends to anyone whose workflow revolves around data. So that just echoes that what I said earlier was that this is for anyone who's kind of working in Python with data. And then we often get questions about, geez, I already know some pandas. Is this going to be redundant? So here was somebody who already knew, had decent experience with pandas, and at first thought that the fundamental work would be redundant and not necessary. But he's glad that he went through it because the subtleties helped him to understand more about how pandas works. And that, in fact, is wound throughout all of our trainings. I mean, these people who are teaching you are phenomenal instructors. They're deep subject matter experts in Python. Some of them are core contributors to the Python language, in fact, or some of the other packages like scikit-learn. But they're also people who have applied this to real-world problems. And so they understand that aspect of it as well. And that's part of what we're trying to get you to learn is not just how do I do X, but why does it work that way, and how do I think about X so that I can do variations on that theme without getting confused or having to find a cut and paste kind of piece of code that I can do because I can actually understand it. So Pandas Mastery Workshop, great class to scale up in Pandas, great instructor, excellent course materials, definitely recommend. That's the kind of comment. People love the design, they love the experience, and they really feel like they got what they wanted. Python for data science, probably the most concise data science primer course you can find, 100% worth it. And then here's one from a NASA rocket scientist, best training class I ever had in the last 17 years working at NASA. So this is typical. We get 95% plus, more than 95% of people say they would recommend our courses to their colleagues. And in fact, rocket scientists is fairly representative of who we work with, right? We work with all of our instructors in the history of the company have always had PhDs in some science, technology, engineering, math field. They're deep experts in the science and engineering as well as in the Python as well as in teaching and applying it. So these are some of the companies, right? Banks and financial services, oil and gas, consumer packaged goods, national labs, just chemicals, biotech, a lot of really interesting domains. All right, so next steps. If you're an individual trainee, you should see our open calendar at enthought.com/training. Here it is. Just a couple of comments about this. It's kind of too much to take in all at once. We run each of the big classes roughly once a month somewhere. We try to hit the big cities. You can see New York, San Jose, Los Angeles, Houston. So we try to get the coasts in the middle. We try to get the big cities everywhere so that people can travel regionally. We also do it in London and Cambridge in the UK. And so just a lot of opportunities to catch these courses. If you want more info or you want a different location, let us know. Go to enthought.com/training and there's a contact form there, or you can email us and I'll give you that contact info here. So also, if you have a group, you should definitely call one of our experts here, one of these account executives, and talk to them about the options, what's the best fit for you, and all of that, all of the details of how we roll it out. You can email them at info@enthought.com. You can go to the contact form on our website there at enthought.com/contact, or you can call the main line and ask for Brian Allison or Michael Millett.
I think we'll go ahead and wrap this up for today. Thank you to everybody for attending. Thank you so much.